Welcome to today's webcast on maximizing value from MLOps. We're going to go through this in a few different topics, so kind of high-level agenda to start with. We're going to look at the opportunity of machine learning, and in particular, kind of why now and why is this a big topic for organizations at this point in time. And then we'll look at different stages in machine learning maturity for different projects and different organizations. From there, we'll take a look in a bit more detail at what we mean by MLOps and what it is that we're trying to deliver. And from that, we'll use a use case example to take a look at a few of the things that help you deliver value from applying MLOps. And then finally, we'll present a few key considerations for delivering value using MLOps. And from there, talk about some next steps that you can take in your organization to get moving with this. As we start this, I'll start with a quick introduction to Thorogood. So who are we and what do we do? The big picture, we help our customers to make sense of and find value in their data. So as a company, we're an independent and specialist data and analytics company with a focus on data engineering, data science, and data visualization. Our approach across all of those is rooted in understanding business goals and using the capabilities of technology to meet these goals. So customers and business objectives are right at the forefront of our approach across all of those aspects. We're also a global company. We have offices and consultants in Asia, Europe, and the Americas. So I'm based out of our Singapore office here. We've also got consultants across the globe. And we offer a full range of services when it comes to data and analytics. That includes data and technology strategies through things like roadmaps, end-to-end implementation for cloud solutions, and then things like user empowerment and analytics services. So landing the solution and then helping you to drive adoption across the company as well. Our customers typically are kind of multinational global organizations. I've listed a few of the customers on the screen. Most of our clients fall into one of four verticals. That's consumer goods, pharma, and life sciences, financial services, and insurance. The reason for that is these industries tend to be incredibly data rich. But as a company, we're certainly not limited to these four verticals. We're working in other verticals as well when there are use cases that meet those kind of data and technology needs. As I said earlier, we're an independent consultancy. We work with a number of the best in breed technologies. So calling a few of those out on the screen. The key thing for what we're talking about today, MLOps, the list of partners that we have got different offerings around that. We're going to talk today from a bit of a generic perspective, but if you want help in understanding exactly how any of these technologies supports MLOps and the things that we're going to be discussing, feel free to get in contact with us and we'd love to discuss how it works, both in specific technologies and in your specific use case. And we've got the range of consultants across the globe that are skilled in these technologies to help you have those conversations as well. So to start on today's topic, I want to start by looking a bit at the opportunity of machine learning and why we're doing it and why we're doing it now. So what exactly is enabling machine learning and AI, and why should we focus on maximizing value in that area? Well, key among that, we're gathering more data than ever before, whether that's tracking consumer behavior through websites, looking at in-store interactions, recording sales across global companies with a single view or a global perspective. And then even things like technology advances such as IoT or increased ability to log and monitor the systems that we have through programs like digital transformation means that there's an increasing amount of information. We have ever more data to analyze. And at the same time, we're seeing more rapid changes in the customer behavior so that there's a bigger value to your organization and to your company of understanding what's going on so that we can track from the data to understand what's happening in customers' consumption patterns and so on. And that will give you an advantage when it comes to meeting consumer desires, leading to successful product innovations, optimized operations, and increased sales. Alongside that, advances in cloud computing have made storing and processing data cheaper and easier than ever. It also makes it easier to explore and experiment with the data to see what of it's valuable, to look at how you can sift through the data to find the insights and identify the actions that are going to help transform your business. And then on top of that, we have availability of open source libraries that make it possible to apply statistical techniques in new ways and in a skill that was previously inaccessible for most businesses. And again, that expands your ability to experiment and innovate by leaning on and leveraging the techniques that are already built and proven by some of the world's most advanced companies. And as these conditions have acted as enablers, we've seen many companies invest heavily in AI and ML to see where they can find value that was previously hard to uncover. And I'll call out a study that MIT Sloan did with BCG. They found that 71% of respondents felt they understood how AI would change the way their business generates value. But in the same piece of research, only 11% of companies reported actually seeing that significant benefit. So at the one time, people are recognizing where the value exists, but they haven't yet got to the point where they can fully see and realize that benefit. So where is that number coming from? That 11%, why is that so low? And why is there a significant gap? And I want to ask you, if you think about your own organization, what's the gap in your organization? Do you see a strong potential for machine learning? And are you realizing that at present? And if not, what are some of the things that are contributing to that gap? So to suggest a few, maybe machine learning and AI is moving forward slower than you'd hoped. We've seen organizations where there are budget constraints and people constraints. Maybe the experimentation phases are taking more time and effort than expected. In other companies, we see teams increasingly getting bogged down in kind of business as usual activities and spending their time running the same algorithms again and again each month. So early on in their cycle, when they first got the machine learning and AI teams, they were seeing some really innovative insights come through. But now that's slowed down and it's difficult to sustain that pace of change. Another major factor that we see is in the business adoption of the ML and AI outputs. So maybe the innovative analysis is happening, but there isn't that translation from the data scientist findings to the business team and to the leadership of the organization taking transformative action off the back of it. Now, I'm not claiming we're going to be able to solve all of those issues in just the 20 minutes or so remaining, but what we will do is propose an MLOps approach to developing models and to efficiently ensuring that the outputs of those models are available in a timely manner. And what that will help do is free up time and energy so that the data science and ML teams can focus on those things. So looking at what the next big innovations are, looking at the transformative actions, and partnering the data science teams with decision makers to drive the business transformation. So to start in doing that, let's take a look at a typical journey that we see across a number of the companies that we work with. So typically, machine learning thinking starts with an investment in experimentation, and that happens as kind of exploratory ad hoc analytics. Often happens in kind of sandbox environments. Those could be local environments, often not integrated with the full organization's data platform. This experimentation stage is great, it's necessary. Rapid experimentation is a key indicator for a dynamic, analytics-driven organization. And so this is something that we want to keep, but then we want to move on to the next stage. So once an analysis runs, once we see value delivered from that, we want to get towards an operational state. And that target is getting something that's automated, integrated with a data platform, reusable, scalable, so we can use it multiple times. We want to make sure that the things that we're outputting are understood by the business and trusted by the business. They're consumed by the business in a way that is responsible, so business decision makers know where the outputs are coming from, they know how to apply them responsibly. An ongoing experiment, so we've got to make sure that when we've built the model, it doesn't just sit static. We keep getting new insights and building more from that. Often in organizations, there's an in-between stage in getting from experimentation to operationalized ML. And that ongoing analysis stage, we see in a number of companies, looks a bit like a step between the two, I guess. So the existing analysis has been built, it's been tested, delivers value, and now it's being updated maybe on a monthly basis, a weekly basis with new data sets. As the new data comes in, some of the data science team we'll take the time to go through and rerun those models. And through that, start to build in a bit of repeatability. So the first time, there are probably tweaks and changes that need to be made in the code to handle the new data. As time goes on, that's reduced, but often still some level of manual work involved every time. Also, tweaks and changes can be made to optimize the model, and those kind of done on an ad hoc basis. And so that ongoing analysis is a really strong tactical approach to providing outputs. And like I said, that's something we see across a number of companies. That's not an uncommon thing at all. But what it does risk is if that ongoing analysis becomes the target accidentally, or becomes an area that you get stuck, that can have some disadvantages. It can take a lot of time, in particular for data science teams, in manually running that process. And so it's important to think from the outset: can you design for long-term use? What can you do to reduce the overhead of that manual effort on an ongoing basis? What can you do to make sure that the risk of manual effort, and particularly if you're making manual tweaks to it, there's a risk from that, in that you could make a mistake? How easy is it to spot when that's happened, and how do we make sure that we minimize problems from that? But of course, if we're saying we want to have tracking on some of those changes, we also want to have that flexibility available. We want to be able to keep an eye to what's happening in the future, and an eye to being able to change and update the model as time goes forward. So we've got to design with that flexibility in mind, but also the ability to track it and audit it as time goes on. And so that's some of what we're really aiming at with this MLOps piece, is how can we think about kind of integrating this whole process together, so that rather than an experimentation phase that leads into ongoing analysis, it eventually goes to operational, or in some cases risks the chance of not getting to that operational state. How do we view this as one process and one life cycle? And so again, encouraging you to think about what's happening in your organization. What's the pattern in your organization for these different steps? Maybe there are specific projects you're working on at the minute that you can think about which stage those are in, and think about, as we talk about some of the MLOps ideas and suggestions, how can you apply some of those things to move from that experimentation phase quicker? So once you know it works, once you know it's adding value, how can we be thinking already about getting to that long-term operational state with all of the MLOps best practices built in to make sure that we're delivering value on an ongoing basis? So with that, I should probably talk a little bit about some of the things that we want to do and achieve with MLOps and what we actually mean by it. So I'll start with maybe not a definition so much as a description, but MLOps brings together best practice data science and machine learning approaches with a DevOps mindset to optimize team structures, to optimize the processes, and the use of tools to increase the pace of model development and deployment. So there's a few things in there that we'll kind of tease out a little bit over the rest of the session. Got the goals on the bottom of the screen though. So what are we trying to do? We're trying to reduce time to deliver value. We're trying to make sure that we can respond to business opportunities quickly. And if we get this right, we get a step change in productivity. So we move from a team building out one model and then having to spend a lot of time running that model to a stage where the team are working on new experiments and new innovations most of the time with minimal effort in keeping those running. Also, when we do go back to update models, we're able to make those changes quickly and robustly with minimal risk, and to be able to push them out to the users quicker. So those are the things that we're aiming at with MLOps. The other thing that's hinted at in that description is that there are a number of levers that we pull to do that. One is team structures. So thinking about who's working on which aspects of this and how the teams are integrating with each other. So if previously you had a machine learning experimentation team and an operations team, how do you get those teams working together? Or even thinking about changing some of those team structures to optimize the way you work. Processes within any organization, there are processes around how you come up with the experiments, how you move from experiments into saying this is something that we now want to do on an ongoing basis. How do you test it? How do you publish it? How do you get the business users involved with the data science teams? And so those processes are something that we look at with MLOps to see how do we optimize those again to get reduced time to deliver value, to get the outputs in the hands of business users to make better decisions. And finally, tools, something that really shouldn't be underestimated in this space. as I said early on, the big vendors in cloud computing and the big vendors in machine learning are all putting a lot of emphasis in MLOps and how you use those tools to optimize how you work as teams, how you work through your organization's processes to deliver models and to deliver outputs faster. And so we've mentioned the relationship between MLOps and DevOps. There are a few things that MLOps specifically builds on top of DevOps. So it lifts a lot of the advantages and a lot of the thinking from DevOps. And so we're used to things like making sure we've got a consistent code base, automated testing, particularly around making sure that everything runs the way you expect it to every time, deployment, and in software development, that's app deployment, and then ongoing monitoring for faults. And so each of those things that happens in DevOps for software development, we're thinking about bringing that into machine learning. And then there are a few things that we add on top as well. So instead of it just being a consistent code base, in machine learning, the model changes every time the underlying data changes as well as the code. So we've actually got to look for the models and make sure that they're reproducible. So if the data set stays the same, we should get the same model output. If the data set changes, we actually want to be looking at model validation, and from that, can we understand how the model's changed and check that it's changed in the way that we expect and in a way that is still consistent with how we want to be making business decisions. Model deployment then, actually in a lot of ways, it's very similar to app deployment. And what it's doing is really, we're leveraging similar technologies for a different set of tools. And then the monitoring, we're monitoring not just for faults, but for accuracy. So when we're making predictions, can we monitor from those predictions to what actually happens in the real world? There might be a time lag, but once that's happened, can we track that accuracy through the system? Even if that's not possible, can we look at the predictions that we're making and see where do those predictions lie in comparison to what we've seen in the real world in the past, and monitor accuracy on that front. And finally, on machine learning, we need to add in model retraining. So with software, once we've deployed it, we kind of expect the same piece of software to run continually on an ongoing basis. With models, we're going to need to update and retrain the model every time we've got a new data set to keep it up to speed with what's happening in the real world. Okay, we've got a question. How much is it feasible to put unit integration performance test cases around your ML algorithm using DevOps? So just to answer that question, it's work in its effort. You have to build the test cases, you have to build them into the system. But definitely when we talk about the functional testing that we've done in DevOps, completely possible to build that in MLOps as well. And actually, MLOps quite often leverages the DevOps tooling for some of those components. So automated testing that you're used to through DevOps tools, you can hook those up with some of the machine learning components. And most of the modern machine learning technologies have specific ways to hook into that DevOps tooling. So it requires a bit of thinking about what that testing looks like, in particular because for a machine learning model, input of A, you might not, in software development, input of A, you get output of B. In machine learning, when you retrain your model, you might not get exactly B. You might have a better, if the data's changed, you want your model to update, give a better understanding. So you might find that the predictions change a little bit and update and hopefully become more accurate. So those tests might be based on kind of thresholds and ranges a little bit more than just kind of if input is A, then output is B. So more thinking required on designing those tests. But from a technical perspective, implementing them is very similar to what we did in DevOps. You've got to design those tests carefully, but definitely it can be done, and it's really valuable when it's done well because it allows you to more quickly retrain the model and have a continued confidence that that's leading to the right business decisions. From MLOps and from the aims we have of MLOps and the targets we have, there are a number of things that we look at in MLOps. This isn't exhaustive, but these are some of the typical things that we would look at with customers who are looking to get more towards that MLOps mindset. What actually we'll do to start in any of those cases is have a conversation, understand where your organization is, and understand where it is you want to get to, what are your objectives and what are your goals from MLOps. And it's important to do that activity because, like with DevOps, different parts of MLOps will be more valuable to particular organizations. And so what I've got on the screen are a sample of some of the things that we've seen be really useful to customers. Model evaluation and model traceability. So that talks to some of the level of testing that needs to be done when you update your model. Replicability is making sure that the model runs the same every time if the data is the same. Also making sure that if the data changes, that we're then able to rerun the model and get an output and a prediction that's based on the latest data, and to do that reliably. That comes in line with automated model training. So when new data comes through, we want to be able to retrain the model, whether that's every time there's new data, or more likely it's once a week, once a month. When we think there's been a change, we want to be able to run that automated model training. Alongside that, versioning and compatibility, making sure that that's in place both for the models that we build and for any dependencies that we have. So if our model is using any libraries in open source technologies, how do we make sure that we're tracking any changes in those so that changes in the software that we're using doesn't break what we're looking at. Scalability, so it's got to run today, it's got to keep running next week, but it's also got to keep running as the data size changes and as we add new markets, new sets of data and so on. Reusable assets is important because we want to build once and then reuse rather than kind of building the same thing across all of our different use cases. If something's built once and it's going to be useful again, then we should be looking to reuse that code, reuse ideally packaged as things like libraries and so on that we can reuse easily. And of course, we need a fast feedback loop. So we mentioned earlier the automated model training. That can be on a scheduled basis. That can also be as we see changes in the data. We ought to be able to automatically detect changes in the data, but also we want to give users a way to feedback and say, hey, it looks like something's happening here. How do we record that kind of user interaction and user feedback as well? And so those different aspects play into different sets of business benefits that come from this. So I've talked a little bit about technically what we mean by each of those, but really they're trying all to build towards the different goals that you have in an organization and that will help deliver ongoing value from these kinds of machine learning projects. So that can be things like continued accuracy. It can be streamlining innovation to make sure that you're getting new and valuable insights on an ongoing basis, and also ensuring that the models that you've deployed and that you've already kind of settled on and proved out with the business are going to improve and are going to keep up to date as the data changes and as customer behavior changes. And so I've kind of grouped these together. They're loose groupings, and there are different benefits that will be of levels of importance to each organization. So like I say, the best way to do this really is to sit down, look at what the different business objectives are with MLOps, where you are currently, and then map how do we get from where we are using some of these approaches, other approaches from DevOps, other approaches from best practices in machine learning, to build towards making sure that we're delivering the maximum value by applying some of these approaches. I'll also touch quickly on what makes a good candidate for MLOps, and hopefully having gone through what some of the benefits are will help understand what makes a good candidate. So the first couple here, the top line, really are about the experiment. So you want to have a successful experiment carried out. Definitely you should be thinking about these things right from the start, but by the time you come to build in all of that automation, you want to have the successful experiment carried out and prove value from the use case that you're looking at. And that should drive clear action within the business. So you're the business decision makers that it's going to influence, and what is it that they need from this model to actually make better decisions. That's how you're going to deliver value from this ultimately. And then across the bottom, some things that you get from MLOps that again identify some good cases to apply this. First, cases where audit is important. MLOps has really good thinking about audit and how you track things and making sure that things work on an ongoing basis. That helps with trust, that helps with reliability within the organization. Also, if there are kind of responsibilities and in some cases even things like ethical AI considerations, audit can be really important in those use cases. So worth thinking about MLOps in those cases where audit is top of the agenda. Other times it's worth thinking about where being able to run more frequently brings benefits, where being able to run on more data sets brings benefits, and the one that I haven't got on the screen, one where being able to update the model frequently. If the customer behavior is changing on a fast and ongoing basis, then you want to be able to update and take that into account as well. With that, I'll talk quickly about something we did with a customer and talk about where we were able to deliver value from that and using some of these approaches. So we're talking here about a consumer goods company where they were using machine learning to create a demand forecast. And they were creating a new forecast every month based on the updated data for each product across a range of online retailers. And where we joined them on the journey, they were running that model manually every month. And there were certain disadvantages to that manual process. So first thing to note, they'd already proved value to using the approach. So they were getting better demand forecasts, and they were using those in their planning. And even the manual approach they had was giving them updated forecasts every month based on the latest data. So like I say, there can be tactical advantage to having that kind of manual ongoing process in the intervening time. But that manual approach was giving them a timeline to get results that was limited by the amount of manual intervention and manual effort that was required to produce those results. And then they were sharing those back with the business teams, so that the business teams were getting results kind of several days after the data set was available. So real opportunity there to speed things up and improve the time to delivery. Additionally, when there were changes to the data or changes to the code, none of that was being tracked. So if there were issues flagged by the business, or if there were questions about which data set things were run on, there was no tracking of that. Reliance on manual processes, we mentioned that already, that's time consuming and an opportunity cost for the data science teams as well. It also meant that there were limited kind of cross checks and validation of the code, so that if there's a mistake in the code, no one was really checking that. Ad hoc changes every month adds to risk and increases the risk of making a mistake that then gets used repeatedly across months. And all of that made it difficult to support over time. So there was no design really for the ongoing use. Software and package updates weren't necessarily considered as much as they should have been, so that where there were package updates, those could flow through into changes in the behavior of the system, so that what was tested on wasn't the same as what was being run in that sense. And then if you're relying on people who know manual processes, there's always that worry about what happens if that one person who knows the process inside out leaves. Is it properly documented? Is it captured in a way that someone else can take over? And actually, we're going to have someone else spending the same amount of time running that manual effort going forward. And all of those are places that we were able to deliver more value by taking some of those approaches from MLOps. So by automating it, just automatically running the process every month, we were able to give more timely insights. So the data was only available every month, but this meant that within a very short period of time, we were able to deliver it. So what previously took days would run in hours. And that has had the added advantage as well that if there were corrections in the data or new data within the month, we have the option to rerun and update the outputs as soon as that's available. We've also established an audit trail that goes across both the code and the models and the data sets, so that at any point in time, when a business user is making a decision, they can go back and trace back what version of code, what version of models, all of that is based on, so that if there are any challenges, any questions that they have, we're able to go back through, audit, and actually reliably tell them this is what happened, this is why it happened. Manual processes completely eliminated, or at least as far as possible. So in some of the systems, there are things like manual parameters that can be changed if you want to change them, but equally the whole process will run automatically every month. So you can keep the flexibility, but have the advantage of no requirement in this case for manual processes. Depends on the exact model, how you want to go along that spectrum, but certainly automation is possible and worth thinking about. And then of course it's designed for stability. So this is planned now to run on every month across all the different data sets and run reliably and be used on an ongoing basis. And that means there's a level of testing that's been applied, there's a level of automated testing that's included, so that we know that it's working on an ongoing basis. So just to kind of close off, we'll think a little bit about some of the learnings that we had from that and other projects about key considerations when thinking about MLOps. First off, we focused a little bit on machine learning and how we optimize that. Data engineering still is a major part of the process and still worth thinking about. Machine learning is complex, and we talked about how that adds some requirements on top of just the DevOps pieces. When we talk about MLOps, we need to think about things a little differently, because machine learning is different from software development, but we can get a lot of learnings from it, but we'll add on top of that as well. The teams need to integrate together, whether that's data engineering and machine learning, whether that's the data science experimentation teams and the operationalization teams. Getting overlaps between those teams, along with the business users, is really important. I'll say one thing we've learned from across customer use cases is that scalability is always more important than you think. If you think you're building it the first time for just a small set of data, just to run 1 month, and maybe it's only one product line or one part of the business. You'll find not too far down the line, if it's successful, which is obviously what you're aiming for, that you then want to run it on bigger data sets, more data sets. You want to be able to tweak some of the things that you're doing, try out different models. And so thinking about the scalability and flexibility early on in the process is worth giving some thought to. It's often easier to build that in from the start, or more efficient to build it in from the start than to come back later on and then have to kind of redesign and rethink things from the start. Testing requires ML skills. If you're trying to operationalize something, if you're trying to build in MLOps, you will need to have some understanding of what's going on in the models, particularly when it comes to some of those retraining components. So again, that can come back to having the teams syncing up and working closely together, or even integrated teams, where the teams building in these MLOps and operationalization parts have ML skills and can reference the understanding from the experimentation. And last, but definitely not least, really important is you need to understand where it is that you're trying to deliver value. Who is your target audience for the outputs? Who is it in the business who's actually going to be making better decisions based on what you're finding? And work with them to make sure that you're providing them with the information that they need, and that they're going to have the confidence to make better business decisions based on what the outputs of the model are. Whether that means you have to take certain things into account when you're building the model, make sure you've got the right data inputs to it and get their help in understanding what those data inputs need to be, but also in terms of making sure that the data is available to them at the right time with any context that they need to make those decisions. So if that means bringing other data sets in alongside the model outputs, there are various different ways you can do that. Again, getting the teams to work closely together is a really key way to do that. That brings me to the end of the content and the thinking that I had that I wanted to share today on why MLOps delivers value, where it delivers value, and some thinking on the specific aspects to look at to get that value. But from it, I want to suggest as a next step, we're happy to come alongside and have a kind of kickstart workshop. Like I said, every organization is going to apply this differently, and understanding how to apply it in a way that delivers value for your business and against your business goals is absolutely key to making this work. And so I'll make this offer. We're happy to have a kickstart workshop. We'll do a few things across that. So level set on the understanding, talk to the wider team about where it is we're trying to get benefits from MLOps, make sure that across our team and your team, we've got an understanding of where that is. Look at the tooling available, understand where your organization is now to come from. So what's your existing structure for machine learning? What do you have in terms of people capabilities and skills that we're leveraging? Understand the projects that you're looking at, what's running already, what are you looking at for the future, and what processes are in place that we can build on. And then from that, look at where the opportunities are to deliver on MLOps. So likely that'll include a lot of the things that I've shown earlier on. Maybe we come up with a few new ideas or different things that we want to put as priorities in that list. So I'd really encourage you to think about it if this is something that is of interest. If you're looking to do machine learning and not doing these things already, it definitely should be of interest, because this really helps to deliver differentiated value and incremental value on top of what you're doing. So if you're interested to look at this stuff, please get in touch with me. My email address is on the screen, and we'd love to talk to you about these things. As I said earlier, we've got consultants across the company and across the globe who can help with this. So we'd love to pick up these topics. Beyond that, we have got more content on MLOps on our website. So if you want to see some of the thinking on it, thorogood.com/events has future events, but also if you go to www.thorogood.com/perspectives, that has some of the existing content, recorded content that you can go and reference, or drop me an email and we can help point you in the direction of exactly what it is that you need if you're looking to pick this up. So don't hesitate to get in touch. If you want to look at some of the other things that we've got available, check out our website. With that, I'll leave you. Thank you for attending, and please do get in touch if we can help you in any way with this.